This clip is the fourth in the series on congruent triangles and shows the third method, the method where you have two angles and a side, angle, angle, side, AAS. Now the rule is that if two triangles have two angles the same and a side in the corresponding position is the same, then they're congruent. But the side must be in the same position relative to the two angles. I think it's best to look at some examples. Look at these two triangles. Those two angles are the same, so are those two, and the side in between the two angles is also the same. So yes, they're congruent. Two angles and a side, and the side is in between the two marked angles, and so it's in the same corresponding position in both triangles, and so they're congruent. Let's have a look at another example. Those two are the same, those two are the same, those two are the same. Once again, two angles and one side the same, and this time the side is opposite the red angle, so it's in the same position in both triangles. So they're congruent, no problem. But look at this triangle. First of all, just by looking at it, you can tell it's too big. It's certainly not congruent to the other two. But look, that angle's the same as in the other two. So is that one. And that side is the same as these sides in the other two. But in this triangle, this side is not in the same position as the equivalent side in the other triangles, because in these two triangles, the given side is opposite the red angle, but this time it's opposite the green angle. So it's not in the same relative position in both triangles, and so it's not congruent. However, what can we say about it? Well, if you know two angles in a triangle, then you know the third, because they must add up to 180. So those three angles are all the same. So the angles in this triangle are the same in the other two. Now that makes it similar to the other two, but not congruent. In fact, it's an enlargement of the other two. Now let's have a look at this rule in practice. Here we have a problem, a circle with points A, B, C, D on the circle, and the line AC intersects BD at the point E. And we have to prove that BE, that line there, equals CE, that line there. Now the method we're going to use is congruent triangles. We're going to prove that the two triangles there, ABE and CDE, are congruent. Let's just think about how we're going to do that. Well, we're told a side. We can't work out any other side, so we need to find two angles the same. And that's what we're going to do. So AAS is the rule we're going to be using, and here we go. We start off by the fact that AB equals CD, and we're given that in the question. We're told that in the question. Those two angles are the same. Why? Because the angles in the same segment rule, which is a rule you should know to do with angles in circles. Also, those two angles are the same because of the same rule, angles in the same segment. Now, we needed two angles. We could actually have worked out the angle there by using a different rule, in other words, the vertically opposite angles rule. We only needed two of those three, and it doesn't matter which two we managed to do. Anyways, now we have proved that the triangles are congruent. Why? Because we have found two angles and a corresponding side. In fact, relative to the green and red angles, the side is in between the two angles. So in the same relative position, they're congruent using the AAS rule. And now we're within sight of the finish line because BE must be equal to CE because they're in congruent triangles. And that ends the proof.